So we left off yesterday at the bottom of our fourth page where it says the zero product property. So in this last part we were talking about how to factor, and I reminded you that factors are just showing us it's putting a function in standard form into intercept form. And the power of intercept form is that it shows us where these functions hit the x-axis. So I want to remind you of something called the zero product property. It says that if the product of two expressions is zero, then one or both of the expressions equals zero. So if you had some algebraic expression a and b, and a times b equals zero, then you know that either a is zero or b is zero. So we can extend this to these functions in intercept form. So consider if we had, if x plus 5 times x plus 2 equals 0, then we know that then either this factor equals 0 or that factor equals 0. So we can say then x plus 5 equals 0 or x plus 2 equals 0. Because remember, there's multiplication happening between those two parentheses. So that is x is equal to -5 then, or x is equal to -2. And that's just found by solving each of those parentheses separately for 0. So let's take a look in Desmos, just as a reminder. So that function we just looked at, that x plus 5 times x plus 2, in standard form, that function is this x squared plus 7x plus 10, right? But we factored it so that we could more easily see our solutions. We factored it to x plus 5 times x plus 2. And notice, sure enough, that's the exact same function. But now we can see where this function hits our x-axis. It hits it at -5 and -2, which were those two solutions that we found. So you're going to start to get really good at just seeing if you have your factors, the +5, +2, then you know that actually your zeros are -5 and -2. So let's apply this to some more examples. So there's lots of different ways that the textbook and people will ask you to actually solve for your x-intercepts. So there's a difference between me just asking you to factor something and me asking you to solve something. So when I ask you to factor something, I'm asking you to put a quadratic function from standard form into intercept form. But if I asked you to solve it, or for the roots, or for the zeros, that means that I want you to take it a step further and actually solve for 0. So if we look at 3a here, we're going to use the same method to factor first that we did yesterday. So it'd be -1, 36 is a factor, -2, 18 is a factor, -3 and 12 is a factor, -4 and 9 is a factor, -6 and 6 is a factor, and then we have +4, -9, +3, -12, +2, -18, and +1, -36. So I want to find which of those factors adds to -5. So it's actually going to be this factor right here, because 4 plus -9 is -5. So that means that this function actually factors to x plus 4 times x minus 9. But now here's the new step. So this was kind of my first step. The new step is, notice this is equal to 0, and then I want to split this. I want to say, okay, well then x plus 4 equals 0, and x minus 9 is equal to 0. So then I can just solve for x, subtract 4 from both sides, so you get x equals -4, and add 9 to both sides, so you get x equals +9. So those are my two roots for this equation. Let's just double check that one more time on Desmos, just so that you can see that that's what this is showing us. So on Desmos, our original equation was x squared minus 5x minus 36. Okay, so it's this big, long function. We factored this to be x plus 4 times x minus 9. Notice, sure enough, that's the exact same function, but this time we can see our solutions are at -4 and +9. So Desmos is always a really good way to check your work. I should label this as kind of our step 2 right here. All right, so B, notice that A asked for the roots of the equation. B is asking us to solve the equation. So it's the same question though. I mean, it just wants us to find those solutions, those intercepts. So again, I'm going to list all my factors. 21, negative 3, 14, negative 6, 7, positive 6, negative 7, positive 3, negative 14, positive 2, negative 21, and positive 1, negative 42. I want these to add up to negative 1, which means they need to be 1 apart. So 6, negative 7 is negative 1. So those are my factors. So that means that this factors into x plus 6, x minus 7 equals 0. And now my second step is I just kind of split these into 2 different problems. It's like x plus 6 equals 0, or my x minus 7 equals 0. So subtract 6 from both sides, we have x equals negative 6. Add 7 to both sides, and you get x equals 7. So there are my 2 factors for part B. You can go check this on Desmos on your own if you want. For part C, this time it asked us to find the zeros, and it has not set the function equal to 0 yet. So we will have to set the function equal to 0, but we're going to start by just factoring this. So negative 14 would be negative 1, 14, negative 2, and 7, 2, negative 7, 1, negative 14. I already see my factor. It's 2, negative 7. It's a positive 5. So this will factor to be x minus 2, x plus 7 equals y, because I had y originally. So then my second step is I'm going to say, okay, now instead of y, my x-intercepts happen where y is 0. So setting that equal to 0 allows you to solve for the x then. So we have x plus 2 equals 0, or x plus 7 equals 0. So then you'll get really quick at this. It's x equals negative 2, or x equals negative 7 is my 2 solutions. Oh, I'm sorry, I messed something up here. That should be a minus 2 because it's a positive. So my solutions are x equals positive 2, x equals negative 7. So those are going to be kind of like the 3 different ways you see this question asked. I had pointed this out for that last practice 2, the 1.2 practice 2. But we have this, we know that x-intercepts of the graphs of y equals a times x minus p, x minus q are p and q, right? We've been working with that intercept form. Because the function's value is 0, y is 0, when x equals p, and when x equals q, the numbers p and q are called our zeros. They're called roots, solutions, or x-intercepts. So you just have to be flexible and understand that those are all the same things. I don't know why we have so many different words for them, but we do, so we're going to make sure that we know what each question is asking for.